We'll be working with some different powers of I, and the goal here for this lesson is to express any exponent of I as one between 0 and 3. So we should be able to perform a substitution for any exponent of I. And in order to do that, let's just begin evaluating exponents of I to determine if there's a pattern. So I to the 0, anything to the 0 power is 1. I to the first power, anything to the first power is itself. Let's figure out what I squared is. And in order to do that, my right column here is going to be my work column, trying to figure out the pattern here for the powers of I. So if I want to figure out what I squared is, I have to first remember, what does I even stand for? I is the square root of -1. And if I were to square both sides here, I would get I squared equals -1. Why? Because when I square a radical, it gets rid of the radical sign. Therefore, I squared is -1. Let's think about what I to the third is. By expressing I to the third, is I squared times I. Well, I squared we just found out was -1, and I we know is I. Therefore, I to the third is -I. Let's figure out I to the fourth. By saying I to the fourth is I squared times I squared. Well, I squared I know is -1. Another I squared I know is -1. And -1 times -1 is +1. Therefore, I to the fourth is 1. Let's figure out I to the fifth. I to the fifth I could express as I to the third times I squared. I to the third I know is -I. That's over here already. And I squared I know is -1. And -I times -1 is +I. Let's figure out I to the sixth. I to the sixth I can express as I to the fourth times I squared. I to the fourth is 1. And I squared is -1. Therefore, 1 times -1 is -1. I to the seventh we could express as I to the fourth times I to the third. I to the fourth is 1. And I to the third is -I. And 1 times -I is -I. Therefore, I to the seventh is -I. I to the eighth I can express as I to the fourth times I to the fourth. I to the fourth is 1, which means the other I to the fourth is also 1. And 1 times 1 is 1. I to the ninth I could express as I to the fifth times I to the fourth, in which I to the fifth is I, and I to the fourth is 1, and I times 1 is I. Therefore, I to the ninth is I. And you should be recognizing a pattern here. 1, I, -1, -I. 1, I, -1, -I. 1, I, -1, -I. 1, I, -1, -I. Yes, this is a pattern. And yes, it will repeat, in which all of the possible output values are right here. There are 4 possible output values for any exponent of I. So really all we have to do is memorize these 4. So our memorization chart is I to the 0, I to the first, I squared, and I to the third. So we should be able to express any exponent of I as one between 0 and 3. And the way we'll do that is by using multiples of 4. Let's simplify I to the 23rd power. So now we're looking for multiples of 4. Why? Because there are 4 possible values. And your new exponent is the remainder. After subtracting a multiple of 4. So let's list some multiples of 4 and see which one gets close to 23. 0, 4, 8, 12, 16, 20, 24. Here are some multiples of 4, in which the closest, without passing it, is 20. So what's the remainder after I subtract 20? That means I to the 23rd I can express as I to the 3rd. The remainder after dividing by 4 is 20 remainder 3. So the remainder is your new exponent. I do not want to pass it because then I'd have a remainder of negative 1. And then I to the 3rd is negative I. Another example. Let's simplify. 2i to the 17th minus 3i to the 102nd power. So now again, we're just looking for multiples of 4. So the closest multiple of 4 to 17 is 16. The remainder is 1. The closest multiple of 102 is 100. The remainder is 2. Therefore, those are our new exponents. So I could express 2i to the 17th as 2i to the 1st. I can express negative 3i to the 102 as negative 3i squared. So I is I, and I squared is negative 1. So let's clean it up and say 2i plus 3. And what I'll do is change the order of this and say 3 plus 2i. May seem silly, but when you're simplifying powers of I, the number has to come first because you have to be in A plus BI form, which means number, then I term. Let's do one more example. Let's do 5i to the 33rd minus 6i to the 54th. So we're looking for multiples of 4. So if you're having trouble, you could list them down the side. The only problem is you may have to take a while to get up there. So now if you're having trouble determining some factors, multiples of 4, just get something that's close and then keep increasing. Now, if I'm having trouble coming up with 33, I know 20 is a multiple of 4, so I can increase from there. 24, 28, add another 4, 32. Well, there we go. So the closest 32, the remainder, is 1. Therefore, this is 5i to the 1st. And now for 54, I know 40 is a multiple of 4, so I'm just going to keep increasing by 4s. 44, 48, 52. Therefore, 52, your remainder is 2. So minus 6i squared. I is I, and I squared is negative 1. Negative times negative is a positive. And let's just switch the order so that it's an A plus BI form.